Okay, I am now sharing my screen. So just so you guys know, and you don't all have to be this way, but you, in school, do you understand that there is a competition? There's a competition in all that you do, right? You're competing against other people. And when somebody does something like this, it just holds the bar up higher. So here's Lena's stuff. Now, Lena's taken a class with me before. So she kind of knows, she's been working on how to do this. But let's just look at the notes that she has on this. She has diagrams. She has some questions. First of all, it's very neat. Notice she put nasa.gov. And then just kind of wrote questions and answers, right? Global warming, causes, effects, what's the difference? That's a really good set of notes for this assignment. Now, obviously, you figure if she's doing this, I would say that she's probably doing this on her notes for classroom as well. And this is just what you're up against. So if I go, hey, you know what a C is? A C is average. And a B is above average. And then A is exceptional. So if your notes and the quality of that, and I'm not saying that it's all right or wrong, if it's like this, then you go, hey, this is what I would consider an A, right? This is great. This makes me happy. If you're not matching up against this, then what grade do you deserve? Well, not an A. Now, and it just seems to me that a lot of people expect minimal work and they expect an A or a B, but that's just not true. Minimal work may get a C, but even that's not necessarily true. Now, Aaron, I don't have yours with me, but that's okay because I thought you did a really good job too. It was very complete. So I want to praise you when you're doing something great. So Aaron and Lena both sent me the notes yesterday. It was really good. But this is kind of the things that I mean. And I just want to show you what A looks like, as opposed to, oh, I did my stuff. And I'm teaching an online course. And the online course, it's kind of frustrating because they're doing stuff and I said complete sentences and their answers are like, here's a single word. And I'm thinking, you're independent. At least I see your faces and I know that you're responding. But in that class, I don't know what they're doing. They could be copying it down and doing nothing. And that's not the point. The point of college is not to get through it. The point of college is to learn something and do it well. To actually be, you should all be above average. Now, it's a competition in that sense, but it's not a competition in the fact that only some people are going to get A's. And I know some colleges, universities are like that. Has anybody gone to another school? For 4 years university or anything? Where'd you go, Isaac?
Oh, sorry. I thought you meant, are you planning on going to another school?
Oh, you're planning. Okay. Where'd you go, Tim?
U of I.
When I went to U of I and took physics, they told me the very first day, 10% of you will get A's. 15% will get B's. 7 or 60% of you will get C's. Do you know how unmotivating that was? Because I didn't think of myself as being, I'm not going to be as good as most of the people. Why bother working?
I don't think they should have said that.
Well, that's what they do, though. It doesn't matter. I could have gotten 94 on the thing. And if I was top 26%, I would get a C. So I hate that. The idea is I want to show you what an A looks like. And all of you could get A's because I would compare you to 30 years of students. And I know what good students can do. So you could all do that and all get A's. And that would make me happy. So you're competing against what I expect versus what would be great. And you could all be great. And then I could give all good grades. So it's not like you're restricted in how well you do. So Tim, let's start with you, bud. Talk to me just in your own voice, global warming and the greenhouse effect. Like, talk to me at the start about the greenhouse effect. What do you know about it?
Well, I learned that it kind of has to do with the concentration of certain gases in the atmosphere. And those gases are like water vapor, methane, and carbon dioxide.
Okay, those would be the primary ones. So that
Yeah.
would be something in your notes you should say primary. Are
Yeah.
there others? Did anybody come across anything else in your reading? Zach, what'd you have? You look like you responded for a second.
I remember writing down
Oh.
the greenhouse gases in my notes, but I think that might have been like, yeah, like ozone is another one. I remember.
Okay,
writing
the
down
funny
ozone.
thing is ozone is another greenhouse gas. Now, what is the problem associated with ozone depletion? Like in your own words, what's the problem with ozone depletion?
Well, I know that the ozone layer does also protect us from the UV rays. So if that's depleting, doesn't it absorb like 98% of those UV rays? So,
Okay, so if I have less, that means more ultraviolet radiation is getting through, right?
yeah.
Now that ultraviolet radiation is doing what to you? What does that ultraviolet radiation do to you?
It helps like build up your immune system through vitamin D, right?
I'm not, you're
Wouldn't
not
it
wrong.
cause skin
Let me
cancer?
rephrase that, Zach. What's the bad thing that ultraviolet radiation can do?
Oh yeah, like skin cancer and
Right?
mutations.
So we don't want that to happen. So a lot of times people talk about ozone and global warming as though it's the same thing. You understand that global warming is about the absorption of infrared radiation, and ozone absorbs ultraviolet radiation. And those are two different things. And we really don't look at ultraviolet radiation as being, oh, it's making the world hotter, right? Because we're going to say global warming. Now, what does the world outside call it now?
Climate change.
Of course, they use climate change. And believe me when I say, over the course of 30 years of teaching, it was always global warming, and now it's climate change because, I don't know. But
Because
we're really concerned
speak-
about global warming. So just understand that. It's about the temperature of the earth getting warmer. Now, ozone, really, when I read an essay from you on this first test, hint, there's gonna be a little essay, I'm gonna ask you about ozone depletion and ultraviolet, and I'm gonna talk to you about greenhouse effect. And I do not want you to conflate the two. I don't want you to mix them up. So that we're depleting ozone would not lead to a global warmed environment, despite it being a greenhouse gas. So I'm not really concerned about ozone whatsoever in global climate change. So let's not even worry about that. I'm going to focus on three gases: CH4, methane, right? CH4, did we talk about that in chemical? Okay. H2O, water vapor, and CO2. And really, I'm not even too worried about CH4 in our discussion. I'm going to be CO2 primarily. Okay. So how does global warming occur? Like Shannon, what would you say on that? How does the global warming with CO2 occur? I don't understand the greenhouse effect.
So global warming is with the CO2, it would be since there's depletion of the ozone layer, that once the UV rays get in, that's really bad because
But that's not making it hotter. So do not say ultraviolet radiation in any discussion of the greenhouse effect. Do not say ultraviolet. Do not say ozone in anything that you write. There's certain words you cannot say. So, Avi, what do you think, man? I mean, true or false? I'm sure in high school, you've all talked about climate change. And you've probably all been told how horrible it is and you're all going to die. Okay, and the first thing that I would say is, well, look, if we're going to give you information and you're going to make conclusions, you better know what that is all about. And I find people who say, it's terrible, we're all going to die. And I go, well, what is it? And they don't know. That should scare every human being, that you're afraid of something you don't know anything about. So we're going to start with the basics. Okay, so here's a question for you. And this is going to be asked on a test. the greenhouse effect a theory or a fact? How many say fact is up, theory's down? Give me an answer. You're all saying fact. Why do you say that? Okay, before you answer that, how about global warming? Fact or theory? Why do you say that?
About the greenhouse effect, I think it's a fact because it's been proven
What does that mean to be proven?
that
That
there
there's-
is viable evidence to prove
Yeah.
that it is occurring.
All right, what is occurring? Your answers are fine, Sam. Let's talk about what is occurring.
Major factories burning coals and creating more CO2.
Are you telling, okay, so Abby's saying that CO2 is going up. Let's see if we can rephrase that better. Like, I want you to say it like an intelligent scientific person. I'm not saying I'm saying, Abby, you're actually right, but I just want to get a better way to describe that. What do you guys think? Julia, how would you state that? What I'm looking for a specific word.
Well, I kind of read about like the greenhouse effect being like the sun, like energy from the sun, like warms the earth's surface or whatever. And it keeps it at like, I read 33 degrees Celsius. That makes like life on earth possible. So like any extra sun energy that like bounces back gets absorbed by greenhouse gases. And so like because of global warming, it's like there's too many greenhouse gases. So
But this is what Abby was kind of talking about. So what's a better way to say there's too many greenhouse gases? What's a more scientific way? Shannon, what were you saying?
Over concentration.
Okay, so that's the word I was looking for, concentration. So what is, now we know how much nitrogen there is in the atmosphere, and how do we answer the question, how much nitrogen? We don't count the molecules, we don't weigh them, we answer it in a percentage of the atmosphere, right? So how much do we have for nitrogen?
I have it somewhere.
78%.
Aaron, you got the answer there?
And she's saying 78.
78%. And what's oxygen?
21%.
21.
1%, right? And what's the third?
Argon.
Argon, good, and that's about 1%, right? And then what's the fourth most abundant gas? And the answer is CO2. So if I said how much CO2 is in the atmosphere, what's the answer?
It varies.
It varies, okay, about what?
It's like 0 to 4%.
Okay, no, you're thinking water vapor. Water vapor may be 0 to 4% of air is water vapor, but what about CO2? In the notes that I've given you in class, does it have that?
It'd just be like less than 1%.
I need more specific, and there's actually two things specifically I want to look for. So, you know, again, you can have your book. You could even you could Google this because you're on a computer. I get it, right? I want to teach you how to learn and how to find information as well as how to understand it. So how much CO2 is there in the atmosphere?
think it says 0.04%.
Oh, it says 0.04%. Where did you see that, Shannon? In my notes?
In the book.
In the book. Okay, so 0.04%. But that's the only first half of the answer. And I'm going to ask you this on a test. 0.0, excuse me, 0.04%. And what does it say in my notes? Do you see that any place?
It says and rising.
And rising. See, so that and rising part, Abhi, is what you're talking about, right? The concentration of greenhouse gases is increasing. Now, I don't want you to take my word for it. What is the graph that would show you this? And there's a name for the graph, and I want you to know it. It's in the book, and it's also online. So you could always Google graph CO2 concentration and tell me what you see. I guess I could do that myself, right?
Would it be the carbon cycle? Or is that different? Okay.
Well, it is part of the carbon. So carbon cycle, when you hear somebody saying it's cycled or cyclic,
So then I'm guessing, I mean, to me, I'd think, oh, it's a recurring process.
so it's going to be a cycle, right? It's going to be recurring. So what I might do is I might even just look at images here, and I'm going to help you find it. And this in here is probably one that you have, right? Is this in the book? And then here's one, Mauna Loa. And actually, you might even argue that it should be 0.042% and rising or something like this. Do you have this in the book? And you see how the black line is showing, sort of showing the average, but the red is going up and down. So why do you think there's a cycle in the carbon dioxide cycle of going up and down? And this is kind of interesting.
Isn't like season changes?
Yeah.
Why? What's going on in the seasons?
During the fall and winter, the plants all die, and during the spring and summer, they absorb a decent amount of the CO2. So when they die, they release it back.
Okay, so you would expect the highest concentrations to be in the fall and winter. But wait a second, it's a world. Isn't the southern hemisphere in summer when we're in winter? So why would that be?
What here? Spell it out first.
Where is most of the land? Northern hemisphere or southern hemisphere?
Northern.
It's all in the northern hemisphere. So there's an abundance of plant life in the northern hemisphere, much more than the southern hemisphere. So we get that cycle. But do you agree that there's definitely an upward trend? This is at Mauna Loa Observatory. And we are definitely seeing an uptick from way back. When I first started teaching, right, I was around here, and I was saying there's 0.03% or 36% and rising. And now it's at 0.42% and rising. So it's going up. Now, this is called the Kiesling curve. So let's see.
Where's Mauna Loa?
Mauna Loa is in Hawaii.
I thought so.
It's a Hawaii. So if I'm sorry, not Kiesling, Keeling curve. Keeling curve. Okay, so there it is. If you want to see what that is, you're like, oh, there's the Keeling curve. Now, I'm doing notes in class. So what I would probably do is I'd just sit there and go, cut, paste. Because are you turning in your notes to me to show you original thought? Are you doing a paper? No. Are you doing notes for you? Then you don't have to do anything other than saying that's a good note. Right? You don't have to reference it. You're not making it your own. You're taking notes. So you're not plagiarizing. But does that make sense, the Keeling curve? And we see that's, and there's a close seasonal variation. So spring and summer, man, it goes up. So yay, we're all kind of happy for this. You know, once we get to the summer, all the plants are there and it starts going down, and then they die off. So we're all happy. That makes sense. So can we agree that to a fact, I mean, and I don't know anyone who would doubt this, carbon dioxide level concentrations are increasing in the atmosphere. And if somebody says,
To a
well,
degree.
do you believe that? I'm like, well, yes, because here's the science, here's the measurement. Same place in Mauna Loa in Hawaii showing this. All scientists agree. And why is that? Why is CO2 going up? Because we do what?
Burn fossil fuels.
We burn fossil fuels. And when you burn a fossil fuel, what are the byproducts? Like when you burn a fossil fuel, what are you supposed to try to get from it?
Energy.
Well, besides energy. I mean, yes. What are the chemical byproducts? I think I
Carbon
told you this.
dioxide.
Carbon dioxide and something else. Super important. Water vapor.
What?
When you burn gasoline, you're producing CO2 and H2O. By the way, when you have on a cold day and you have the tailpipe, you get steam coming out of your tailpipe in the car. By the way, is steam water vapor? Yes or no? Yes or no? Steam water vapor.
Yes.
No,
Why not, Sam?
because water vapor is invisible.
Water vapor is invisible. Do you see steam? Yes. So it's liquid. So there's water vapor in the air, but it condenses into a cloud and then it evaporates. Just so you understand it. But steam in the cloud is visible. So I see it as liquid water. Now, I want it to burn CO2 and H2O. That's what I want it to do. Now, sometimes there's other pollutants in it, right? There's other pollutants in it. Hydrocarbons, just things that aren't necessarily good. Dirt, it's grimy. It's like it's smoke, ash, that kind of stuff. There's something else that happens when your car doesn't burn fossil fuels well enough. And if your car does this, there's a problem and you should get it fixed. And a lot of times you have to go to like the emissions check and they check for this. What are they checking for?
Your car is releasing an excessive amount of carbon dioxide.
Not carbon dioxide, because they're okay with that. That's what you want it to do. If it doesn't burn completely, what do you get instead? And the answer,
Monoxide.
Carbon monoxide.
carbon monoxide, CO. Now, carbon monoxide causes, it's a poison to you. Has anybody here ever had carbon monoxide poisoning? I have. Scary as all hell. I was at home. I was with my parents' house and I was sleeping and I heard my sister complaining about something in the middle of the night. I woke up, I'm like, God, my head is just pounding. It's the worst headache I've ever had. And I walked to go get some aspirin and I passed out in the hallway, gouged my back as I just fainted, passed out. Luckily, my dad was a very quick-witted person, opened up the window and turned on a house fan and got fresh air in there. And the furnace had been backing up carbon monoxide into the house. And near lethal levels in the basement. Up top, it wasn't lethal yet. It was just causing all sorts of problems. Why is carbon monoxide poisonous? Do you know? Does anybody know why? I just think this is...
It's a singular oxygen molecule, and you require, well...
Okay, Sam, that's fine. You require O2. Your body does. By the way, do you know what carries O2 through your blood? Does anybody know?
I want to say hemoglobin.
Yep, that is correct. Hemoglobin, right? That's what carries the oxygen around your blood. And your body goes, I need oxygen. Your brain goes, I need oxygen. Hemoglobin likes carbon monoxide better. So when you have carbon monoxide in your system, the hemoglobin carries that instead. And the oxygen's, you're depriving your brain of oxygen. And pretty soon you pass out of it. What do you call the deprivation of oxygen?
Asphyxiation.
Well, maybe. Anybody know what that's called? Is it called apoxia? Hypoxia? You ever heard of that? You guys remember the golfer Payne Stewart when his airplane died? When he died in the airplane crash? Their plane had a leak and everybody passed out. And they're just sitting there like this. And all of a sudden they don't have enough oxygen. And the next thing you know, they're like, they fall asleep. They don't even know they're getting woozy. And they fell asleep. The plane kept going up. They ran out of oxygen. They died. Plane flew till it ran out of gas. And then it crashed in the ground in South Dakota. Horrible. I was watching it live on the news. And he was my favorite golfer. And I was like, I'm really bummed about this. Anyway, that's what you would do if you had carbon monoxide poisoning. Then you don't want your car to do that. So carbon monoxide is a pollutant. That is a dangerous thing because it could kill you.
Well, that's why you don't run your car with the garage door
With
closed.
your garage door, right? I mean, I always start my car with the garage door and then open it up. But you have carbon monoxide. There's a certain amount of carbon monoxide, and it will kill you. It's a pollutant. Now, do you think carbon dioxide is a pollutant? Yes or no?
Well,
Oh, a little bit different in the answers. So my personal thing is I would do this. We exhale it. Carbon dioxide at levels in the atmosphere will not kill us. It does not cause poison. But according to the EPA, it is a pollutant. That means you're polluting right now by breathing. Why do you think it's called a pollutant? There's a reason for it. You need to know this.
Well, I feel like it's because of just the sorry, I'm blanking out on words. The factories when they're producing things and it just mass produces all this CO2.
See, here's the funny thing, Isaac, right? People will often use that code. Well, all these burning in your cars, they're all polluting the atmosphere. And they're polluting it with CO2. Come on. That's not polluting the atmosphere. I mean, it could lead to an increased concentration of greenhouse gases. I get that. But it's not a pollutant. I mean, it really is not. However, the EPA has now called it a pollutant because now you give the government power to control it. That's why it's called a pollutant. It's not a pollutant, but now that you call it a pollutant, now the EPA is a federal bureaucracy that has no authority. I mean, they have no accountability to the voters. They can just go, this is what you have to do. And everybody goes, oh, I have to do it because the EPA said so. I didn't vote for an EPA official. So I just want you to know that it's a political response to EPA.
Now the EPA is corrupt.
Because now you can control people. You can make regulations and say you have to abide by this.
Now the
I personally
EPA
don't
is
think
corrupt.
I'm not saying it's corrupt. I'm not saying that they're wrong. I'm just saying that's why. Right? I'm not going to tell you a judgment on whether or not EPA should control it. I'm just saying that's why we have this discussion. Okay, so carbon dioxide is definitely going up in the atmosphere. Is everybody okay with that? So, I mean, would you agree that's a fact? I don't know anybody who says it's not. So now the question is, what is the greenhouse effect? And the answer, the greenhouse effect is a fact. Sam, why is it a fact? Because this is the way the physics works. So what I'm going to do is I'm going to show you basically how the physics of the atmosphere works. So the first thing we do is we draw the Earth. And whenever I'm drawing a cross section, I'm going to say the ground always is this. Have I done this with you guys yet? Ground?
Yeah.
And then up here, I'm going to draw what would this be? The sun. And then over here, I'm going to go this. Whoops, I'm going to be neater. This is what? What am I trying to represent? This is the atmosphere.
Atmosphere.
Okay. So the sun gives off, fill in the blank.
Energy.
It gives off energy. In what form?
UV rays.
Well, Abby, there's something you said. I don't want you to say that anymore. And we talked about it the other day, and you said it, and Lena, you said it earlier. It gives off what? Don't say rays.
Electromagnetic waves.
Okay, that's even way better. Electromagnetic waves, electromagnetic radiation. Now, we are going to say that most of it is short wave solar radiation. Short wave meaning UV, visible light, and what we call near infrared. Meaning it's just, remember, ultraviolet is just shorter than violet and infrared is just longer than red. It's still considered shortwave radiation. Now, that shortwave radiation comes into our atmosphere because it travels through space. What happens to this radiation? What three things happen to the radiation?
Isn't some of it reflected back into space?
Okay, so the first one is it's reflected. It's reflected. That means it's not even there. It's not even coming in. Now, this is a third unit stuff, but I might as well, sometimes you need to get words more than once. What do you call how much is reflected of the earth? Does anybody know that? Starts with an A. L.
Albedo.
It's called the albedo. And it just talks about how much is being reflected. But here's the thing, Tim. This is in the atmosphere. What's reflecting? Because I'm not looking at the earth. I'm looking at what's reflecting. What's going to be the best reflector?
Is it visible light?
No. What is reflecting the incoming shortwave radiation, of which that's visible light?
The ocean?
It's in the atmosphere. We're not at the surface.
Is it the ozone there?
Not ozone.
Is it greenhouse gases?
Nope.
Water vapor.
No. Tim, what does greenhouse gas, what makes it a greenhouse gas?
Oh, it absorbs.
Absorbs. And what we're talking about is reflected.
Gotcha.
See, there's a difference. And that's a really important distinction. You have to understand reflection is not absorption. So what reflects radiation? What's the number one thing in our atmosphere that reflects the most amount of radiation?
Aaron says water vapor.
Water vapor is invisible, doesn't reflect. Clouds. Clouds are the biggest reflector of all incoming radiation. If you don't believe me, let me show you something. I'm going to show you our satellite page for meteorology. Ooh, we're having some internet issues, it appears. Holy crap. There we go. What do you see? You see white stuff, which we call clouds. And these clouds are doing, and there's, what else reflects at the ground? What's up here that's not moving? That's reflecting.
Snow.
Snow, right? Snow and ice. Now, all the things that are moving, that's clouds. This over here is actually fog. But you see the clouds. Why? Because the clouds show up as reflective. The oceans don't reflect very much at all. They absorb almost everything. So if I go to the globe, there's the entire hemisphere. And we see all those clouds. That's reflecting about 20% of what's coming in. About 20% of the sun's radiation is lost by clouds. Now, would you agree that if I changed the cloud cover, I would change how much radiation is got to do something other than being reflected? Keep that in mind. The other thing that can reflect in the atmosphere are, so I'm going to put clouds, aerosols. Isn't aerosols the other thing in my notes about things in the atmosphere? Aerosols are particulates. Give me some examples of particulates in the atmosphere. So we're going to list them. We're taking good notes. So we're going to list the particulates. What have we got? If you're in your notes, what does it say there?
Smoke.
Smoke. From like things that burn, right? Forest fires especially. What else?
Mining.
Well, okay, so
sorry.
I'm not asking you necessarily for the cause of that yet, Isaac, although I will. But what are you trying to infer? What's in the air? Smoke.
Dust.
Dust. What else? Think volcanoes.
Ash.
We talked about this the other day. Ash. Right? Another big source of aerosols in our atmosphere is something known as sea salt. Have you ever gone near the ocean where you can taste the salt in the air? You're like, oh, it's salty air. You know why? Because there's salt in the air, and your tongue's sensitive to that. So there's actually salt particles in the air.
Would pollen count?
Pollen could do that. Anybody who's got allergies knows that's the case. But smoke, ash, salt, sea salt, volcanic ash, dust, fires, that kind of stuff, those are all highly reflective. And so that plays a role, these aerosols. So what do aerosols do in the atmosphere? Well, there's two things. The first one is it reflects incoming solar radiation. And it's actually about 6%, well, a little bit less than that, a couple of percent of the incoming radiation is reflected by smoke in the atmosphere. And obviously, if we have big forest fires like we had last year, there's a lot of smoke in the air and it shows up really well on satellite. Okay. What else do aerosols in the atmosphere do as far as what?
Say that again.
What else do aerosols do in the atmosphere?
No, they reflect.
And
They're cooling the atmosphere.
well, they certainly could, right? Although it's not as easy as that, but they reflect, but there's something else. They act as CCN. Oops, as CCN. What's CCN stand for? It's in the notes, in my notes. So what's CCN stand for?
Aaron says cloud condensing nuclei.
Yeah, or condensation. So cloud condensation nuclei. And we're going to talk about this process later in the semester. But basically at the center of every cloud droplet, remember we said clouds are not vapor, clouds are liquid water. And for that liquid water to condense, it needs to condense onto something. Those are aerosols. So water vapor will actually collect on a piece of dust or pollen or something like that. And it serves as a cloud condensation nuclei, or nucleus, singular. So those are the two big reasons to have aerosols. the reflection of incoming solar radiation and the U being used as a CCN. Okay, so I'm going to ask you this on a test. Does that make sense to you? I mean, if you don't understand something I'm saying, just say, oh, I don't understand what you mean by that. But I hopefully that's pretty straightforward. Okay. Now, we're not going to get into this right now, but sometimes, you know how we see the sky being blue, it's a scattering. Sometimes that scattering goes back to space. And so we lose some of that, but we get some reflection. By the way, the albedo of the Earth is around 30. 30% of what comes in is reflected. Now, some of it's from the ground. So some of it's from the ground too. And so all of it comes out to be 30. And we'll deal with the exact numbers later on. But there's reflection. Okay, I said 3 things happen to radiation as it comes in the atmosphere. What's the second thing that could happen to it?
It gets absorbed.
It gets absorbed. Okay, so it gets absorbed is a possibility. Now, we already know that some of the ultraviolet's absorbed, right? Ozone absorbs it. So we already get that idea. And there's some else that's absorbed, especially up in the high thermosphere, where those gases are absorbing radiation. That's why it's so warm in the thermosphere. It's because the gases are absorbing incoming solar radiation, especially even shorter than microwaves like X-rays and gamma rays, right? You understand there's X-rays coming from the sun and gamma rays. Those would kill you. That's bad if you got that. Luckily, way up in the high thermosphere, there's gases that absorb it. We don't have to worry about it. If you went to space, what would you have to wear? Like you're on the moon. You'd have to wear a spacesuit, primarily because without it, the radiation would kill you. The sun would kill you if you didn't have protection. So, you know, it's not that the pressure is so low that your body's going to explode. It's the fact that radiation is going to do bad things to you. So it's really a radiation suit. Okay, and I'm going to come back to this in a second. What's the third thing that could happen to radiation as it goes into the atmosphere? You're missing the obvious one. And people always do this. So like, okay, it's reflected. Okay, it gets absorbed. What else could radiation do as it goes through the atmosphere?
Pass on through.
Right? It goes through it, passes through. It goes through the atmosphere. If it's not being absorbed, if it's not being reflected, it goes through. And what we're going to say is that this radiation, if you don't worry about the reflection, most of it goes through. In fact, we would say about half, and I'm not going to get into specific numbers, okay? So please don't, well, Paul said 50%, and I've seen someplace else it's 47%. It's about half is absorbed by the ground. To be absorbed by the surface. Now, if it goes through the atmosphere, meaning it's not absorbed, what do we say it is? What do we say the atmosphere is if it's not being absorbed? There's a word for that. Anybody?
Like transparent or something?
That is the correct answer. It is transparent. So what I need you to write down is that the atmosphere is mostly transparent to incoming radiation or incoming solar radiation. Not all of it, but mostly. Now, what does the ground do when it receives and absorbs radiation? So I'm going to ask you this question again, and I want the best answer. You're probably going to give me an answer that's not necessarily true. But you could say it, and I'm not going to be upset by that. What happens to the ground when it absorbs radiation is the question. What do you think the answer is going to be? Zach, what do you think that answer will be?
I was just about to like search up on Google. Is that
I don't want you to do Google yet. I'll tell you the answer. I just want to know what you think it is. So I'm telling you the ground is absorbing radiation. What do you think is going to happen to it?
oh, is it plant life? Like to help with photosynthesis?
Oh, okay, you're not wrong. I wasn't thinking that way. I'm talking about the surface of the earth, not plants, but
Okay.
the surface of the earth, it's absorbing radiation. What happens? Javi, what would you say?
Would it get warmer?
Okay, the answer I was expecting you to say is it would get warmer. Is that a true statement? Do things get warmer because they absorb radiation? Yes or no? Actually, I'm going to go maybe. Did I talk to you about the boat and the hole in the boat, or is that another class?
Did not.
Okay.
Probably another class.
So imagine that I'm sitting on a lake in a boat, and the boat has a hole in it, and there's water coming into the boat. Will the boat sink? I want you to imagine you're sitting in a boat on a lake. So you're not at the shore, and there's water coming into the boat. Will it sink? Do you look at that and go, okay, I'm dead. I'm going to drown. What would you do?
The boat wouldn't sink until a certain amount of water took over the weight of the boat.
Okay, Shannon, how about if I asked you this question? Will the water level in the boat rise because water's coming in?
Yes.
Do you all agree with that? Okay, the answer is not necessarily. What would you do if you had a boat in the water, that water was coming in? Physically, what would you do?
Patch it up.
Well,
Patch
let's
up
say
the
you
hole.
can't patch it up.
Make another
Abandon
hole
ship.
same level.
Well, I mean, what would be? Wouldn't you try to take water out of the boat? I mean, if water's coming in, wouldn't you grab a cup or something or try to scoop the water out of the boat? So would the water level in the boat go up? The answer is, well, not if you can take out as much or even more than coming in.
Oh.
Does that make sense?
Does that relate to the carbon cycle?
Well, not the carbon cycle per se, but does it relate to this? What is the Earth going to do? Well, the Earth is going to give off radiation as well. I'm going to draw it differently. Do you agree that the Earth is going to give off radiation? And that's really what, oops, I really wanted to do this. That's really the answer. What happens when the Earth absorbs radiation? The answer is the Earth also emits radiation. Everything that absorbs radiation also emits. Now, imagine on a summer afternoon, and it's 4 o'clock in the afternoon. That's about the hottest time of the day. Now it's 6 o'clock. What's the temperature doing? Do you agree that the temperature is getting cooler as you go into the evening? But the sun's still up. So are you getting radiation in at 6 o'clock in the evening? Yes. But what's the temperature doing? It's going down. Because as long as more radiation goes out than comes in, the temperature goes down. So the temperature will only go up if more comes in than goes out. But if more goes out than comes in, what will the temperature do? Go down. So just because the sun's out doesn't mean temperature is going to go up. It just means I'm getting radiation in. But all things give off radiation. The thing is about the radiation that comes out is that the radiation coming from the Earth, and I've drawn it this way, is different. It is what we would call long wave terrestrial radiation, which is infrared. Now, another way that a lot of times people will say this, OLR. This is actually the common meteorological term, OLR. And OLR says outgoing long wave radiation. Now, what happens to that outgoing long wave radiation coming from the surface?
Would some of it get absorbed
By
the atmosphere?
what specifically?
Carbon dioxide?
So generally speaking, it's absorbed by what?
The ozone.
No, not ozone. Don't say that.
Right.
What absorbs outgoing long wave infrared radiation?
Albedos? No. Greenhouse gas.
Notice that the greenhouse gases did not absorb what's coming in, but it absorbs what's trying to get out. Those greenhouse gases, and what are they? What are the three primary ones?
H2O.
And
CH4.
Absorb more than 90% of the outgoing radiation from the Earth. So the atmosphere is absorbing outgoing long wave radiation from the Earth. Then what does the atmosphere do? Be careful of the answer because I know what you're going to want to say. Tim, what do you say?
I have a question.
Okay.
Does the atmosphere reflect long wave radiation?
Okay. By the way, Tim, that's a damn good question. That's not just a good question, it's a damn good question. And the answer is not very well.
Okay.
So even if it did, if the radiation coming from the Earth is reflected, it would go right back to the Earth. Did it ever come out? See, that's the way you want to think about it. If the radiation is reflected and it's traveling at the speed of light, 186,000 miles a second, did it ever really come out of the Earth? And the answer is no. It never lost it. But it doesn't do a lot of reflection anyway. So the greenhouse gases are absorbing this radiation. And what did I say you should answer when something absorbs radiation? What should you say? What did Abhi say that was wrong? That something absorbs radiation.
You said that it heats up.
Right. You said, well, you said it heats up, gets warmer. And that's not necessarily the case. But what is the correct answer? When something absorbs radiation,
Gives it off.
it also gives it off. And what do you call the giving off of radiation? Use a better word. What's a better word than gives off?
Emits.
Emits, right? It emits radiation. The question is, where is the atmosphere emitting radiation to? Where's the radiation going? What do you think, Tim? Radiation can go out to space, or it can come back to Earth. Does that make sense to you? If the atmosphere is absorbing radiation, then the radiation it emits will either go out to space and it's lost forever, or some of that radiation comes back to Earth. So what do we call this radiation coming back to the Earth? That's called the greenhouse effect. Right? That's the greenhouse effect. This part of the radiation that's absorbed by the atmosphere that radiates back to Earth. So what I'm saying is that you're over here and you're on the Earth, and I said, okay, guys, what causes, what is your source of radiation? I'm standing on the Earth and I look up and I go, what's giving me radiation? What's the answer? How would you answer that? Isaac, what do you think, bud?
So your question is, what's giving radiation?
I'm standing on the Earth and I'm looking up. There's radiation coming at me.
Okay.
As I look up. What's giving me that radiation? What's my source of radiation?
Well, the main source would be the sun,
And
right?
the second source?
The second source would be the greenhouse gases in the atmosphere.
Yeah, but right? The atmosphere. But you made an interesting comment, and I don't know if you could back that up. What's the main source? Is it the sun or is it the atmosphere? And the answer is, it's the atmosphere.
Yeah.
It's really not what people think. It's the atmosphere. The atmosphere is huge. I mean, is it the main source? I don't know. Maybe that's a false statement, but it's a lot more than people would realize. Okay. So what that means is if I had no atmosphere, what would happen? What would my only source of radiation be?
Sun.
The sun. But because there's an atmosphere, I have more radiation coming in. Therefore, my temperature is higher. So now in the notes, look at my definition of the greenhouse effect. And if you could just read that to me, that would be great. Julia, do you have that there?
I don't have it up right now, but I'm pulling it up.
Okay. Well, does somebody else have it? Ryan, do you have it?
Is it in the Unit 3 notes?
Unit 1 notes.
Oh.
I mean, we're going to go into more details about radiation then, but this, you know, I never know what to do in this class, Ryan. I don't know where to start because it's all kind of combined, right? I can't separate, I can't talk about one thing without talking about a lot of other things. But it's in the Unit 1 notes. Does anybody have it written? Has it there that they can speak it out loud?
Yeah, I have it.
Go ahead, Zach. Did you read it?
The greenhouse effect is the fact that states that the average global temperature, 15 degrees Celsius or 59 degrees Fahrenheit, is warmer than it would be given the Earth's proximity to the sun because the gases in the atmosphere absorb and re-radiate infrared radiation. Global warming.
So we just stop with that. So the greenhouse effect, and I said, is a fact saying that the Earth is warmer than it would be without gases, without these greenhouse gases. Because There are gases that absorb and then give off, re-radiate, give off energy to the Earth, keeping us warmer. And the temperature of the Earth would be based on what if there was no atmosphere? What's the word I say that the temperature of the Earth is based upon? What's the word that's in there? It says proximity.
Yeah.
What's proximity mean?
How close we are?
How close you are, right? If the Earth were closer to the sun, what would the Earth be?
Hotter.
And if the Earth were further away from the sun, it would be colder. And the Earth, where it is right now, based on our proximity to the sun, the temperature of the Earth would be, on average, below freezing.
I
Like
believe
negative.
it's called the Goldilocks zone.
Yes, because, well, it's the Goldilocks zone, Shannon, which is great that you would say that because it's just right. But here's the thing. Earth life would not happen without greenhouse gases. So this is a question I would always ask people. Are greenhouse gases bad? And the answer is no. Without them, we'd all be dead. Greenhouse gases are vitally important. We need to have them. We need the greenhouse effect or also I'll be dead. It's why the temperature fits, Shannon, into this Goldilocks zone. Man, it's great for life. And it's great for human life. So with that in mind, that's what the greenhouse effect is. Now, the way that I want to look at this, and I'm just going to kind of talk about it. So just kind of pay attention to me, see if you can focus on this. Are you okay with focusing? Okay, so imagine that I have a guy out in space throwing ping pong balls at me. Okay, and I'm like, I don't want these ping pong balls in my house, and I'm going to throw them out. The problem is, the guy's throwing ping pong balls, and I have to throw all of those ping pong balls out. So if he throws in 100, I have to throw out 100. The problem is, with every ping pong ball I throw out, there's a guy above my house or whatever, and he collects the ping pong balls and throws them back to me. So for every 100 ping pong balls I'm getting in, I've got to throw out 190 ping pong balls. Maybe even more, because he keeps collecting the ping pong balls and I have to keep throwing more and more out. So to keep up with the balance of what's going in from the sun versus what's going out from the Earth, I've got to throw out more ping pong balls. Well, more ping pong balls throwing out is radiation emitted. The Earth needs to emit more radiation than what I would have needed before. Do you know how an object emits more radiation? It gets hotter.
Yeah.
Objects radiate more energy. You should write that down.
Sorry about that.
Hotter objects radiate more energy.
Sorry, what object?
Hotter objects. Anything that's warmer, it gives off more radiation. Or maybe, Abby, you could think of it this way. It radiates at a higher rate. In other words, I'm throwing ping pong balls a lot faster to keep up with the 100. So if it was just a guy throwing in 100, I could be like, so watch, I could just be like this, throwing the 100 ping pong balls out as he's throwing them in, right? I'm just fine. But now somebody's catching the ones I'm throwing out and throwing them back to me. I'm like, oh, damn, there's way too many ping pong balls. So now I have to throw faster. Well, giving off more radiation means that I'm warmer. So the Earth is warmer because of this fact. So what are we saying with climate change, with global warming? What we're saying is that if I put more greenhouse gases into the atmosphere, that's going to result in me at the surface being warmer. Because now he's throwing back more than 90% of the balls. Now he's throwing back, let's say, 93% of the balls. Means I've got to work harder to get him out, which means I'm warmer. But where am I warmer? I'm warmer
Surface.
at the surface. And that's what we're worried about in terms of global warming. What happens if we're warmer at the surface? And when I say worried about, I'm saying we need to understand what that would do if we're warmer at the surface.
Well, wouldn't it melt like ice? Or
Okay,
snow?
well, there's one effect. If it's warmer at the surface, won't that melt more ice? Sure. Anybody know what the ice layer of the atmosphere is called? Or of the Earth? It's called the, oops, no, I spelled wrong. The cryosphere is the ice covering. So if the Earth were warmer, we would have more ice melting. And that's one thing.
And I think like the ice melting also results in some gases being released from the past.
Okay, so in that, and Shannon, that's interesting. Where did you hear about this?
Something I've heard. So.
Okay, so what they're saying is that some of the ice, there might be trapped methane. And so if the ice melts, it releases methane, which increases the concentration of the greenhouse gases. The question is, and this is kind of new in the way of research, is how much more increase in the gases will lead to how much more temperature? Right? It's almost all of it's being absorbed anyway. So how much does adding more greenhouse gases? So what we have to do is we deal with something called the equilibrium climate sensitivity, the ECS. And the way that you will hear this framed in discussions is usually this. The ECS is, if I doubled the amount of CO2 in the atmosphere, what will the final temperature of the Earth go up by? How much will that be? So let's do this. What is the ECS of the Earth? For the current generation of Earth system modeling, this thing called CMIP6, the range of equilibrium climate sensitivity, a hypothetical value of global warming at equilibrium for a doubling of CO2. So now they've given you in the parentheses that definition is how much? (1.8 to 5.6 degrees Celsius). Is that an answer? Or is that a range?
Range.
Where's the range coming from?
Models.
Models. That means, are we measuring this or are we just assuming that our model is good? Here's Wikipedia. Okay, now, this is what cracks me up. And you will hear this if you listen, but this always makes me laugh. If climate turns out to be on the high side of those estimates, then the Paris Agreement, which we talked about, will be limiting global warming to below 2 degrees Celsius. And that'll be difficult to achieve. So the question is, if the Earth warms by 2 degrees Celsius, let's just go on that 2 degrees, maybe on the low side of this. Is that bad? Is that bad or good? What do you think? I'm going to give you my opinion for a second, okay? When I listen to the discussions on CO2, this is my belief, okay? When I listen to that, I look for the following phrase. And when I hear that, I'm going to disregard this. And the statement is, it's an existential threat. What is an existential threat? It means our existence is threatened, like we're all gonna die. Soon as someone uses that term, I'm going to discount you from being scientific to going into the political realm. Because that drives me crazy. That's my opinion. Now, if I said to you, will 2 degrees Celsius cause an impact or a change in our environment? Then the answer for me would be, well, of course. But if there's a change, what's the next question? Is that a good change or a bad change? And that's where we start getting into disagreements. What do you think good changes and bad changes would be? So let's go with bad changes. If it goes up 2 degrees Celsius, and let's even say it goes up 3 degrees Celsius. And if you do a lot of work, you'll find what I just showed you, what I just showed you about the range 1.8 to 5.6. Those are the model outputs. And there's a lot of scientists who go, those are too high. It's probably 1.3 to 2.6, something like that. It's not, it's under 3 is most likely. And that's for doubling. Here's the Kiesling curve. From 1980 to 2020, we're going from 340 to 420, let's say. So how long will it take to go from 340 to 680? Okay, so do you understand that to know the forecast of a doubling of CO2, we would have to know how quickly do we double the CO2 concentrations? If I'm going to know that, what would I need to know? Here, you know what I'm going to do? Because this is going to be, I need to have a discussion with you about this, so I need a lot of interactivity. So I'm going to do the note stuff, right? And when you're doing the classroom notes, that's, Shannon, that's purely come to class prepared by reading the book first. And then when you get my notes, then you're going to go, this is what Paul thinks is important. And what am I going to test you on? Things I think are important. Okay, so we're ready to go. I want to have a discussion. I want to go back to, I want to define one more thing before we have that kind of pure discussion. Abby said something about melting the ice. Why is that? Why would that matter?
So let's take Antarctica for instance. Well, I've seen this on the news mostly, but I'm not sure. Wouldn't sea levels rise if more ice melts?
Does melting ice raise sea levels?
I would say to a certain degree, yes.
Maybe. If I put ice in a glass, when the ice melts, does that change the water level of the glass? Nope. So there's 2 types of ice in the world. What's the ice that's sitting in the water now called? It's called sea ice. It's most of the North Pole is sea ice. Now the Southern Hemisphere has continental ice. It's sitting over continent. And what continent is down there?
Antarctica.
That's Antarctica. So up in the Northern Hemisphere is mostly sea ice. So the melting of sea ice, not that much. So let me show you something that's kind of interesting. So if I do Cryosphere, Crimea Riverosphere. Cryosphere, sea ice. And here we have the cryosphere. Wow. How's your internet? Am I coming through okay, or is my internet bad?
Fine.
You're coming through fine.
Okay. That's, for some reason, things are just really slow. Yeah, you know what I'm going to do? I'm going to do this. Sea ice extent. Okay, here's sea ice page. So there is sort of a historical time series. Remember we talked about time series of the sea ice. And we have this normal amount. And then we keep going about what's the global sea ice. So this goes January to 79 to January of 2021. And notice the variability goes up and down. How far away is that? Does it look like it's really changing a lot? Now look at the Arctic sea ice. What would you say about that? It looks like it might be going down a little bit. So I can look at a page here, and this is going to show me the sea ice page. And this was as of September. So notice the gray is what's been, but basically is average. So we're definitely in the Arctic Ocean, less sea ice than maybe this 30-year average from 1981 to 2010. Here's the ice extent. We're not as bad as some areas. There's a variety of spread. There are variances in how much sea ice there is, but we definitely, I mean, I would say, from my opinion, which has some credibility, is that we're definitely underneath the amount of sea ice that's happening in the Northern Hemisphere, at least. We're below normal. And I think this is a pretty good sign of what we would call climate change. Like, do you guys follow this argument? Have you ever had the discussion about climate change in any other class? Do you know what some people call other people if they're not worried about climate change?
Hoaxers.
Climate denier.
Okay, they call them climate deniers. Okay, so Ryan, that's exactly right. I think that's disgusting. Personally, right now in our society, I am appalled by what I see. People call other people liars, misinformation, disinformation. They censor you because you believe something different. I want to say, who's the arbiter of truth? You're a science denier. You're a climate denier. Okay, shut up. That's what I say. Science is about people who come to different conclusions. I was thinking about this while we were on break. I was like, what did they say about Copernicus? Actually, it was more Galileo, but Copernicus. What did Copernicus do, by the way? Do you guys know anything about the history of science? Copernicus is the one that says, you know what? The sun is at the center of our solar system, not the earth. We have what we call a heliocentric solar system, as opposed to, if it's earth-centered, what do we call it? What's the prefix for earth? Zach?
Geocentric.
Yeah.
I'm sorry, Shannon, what did you say?
Was it Terra?
No, not, Terra is a good word, but the heliocentric, a heliologist is one who studies the sun. What do you call a person who studies the earth?
Geologist.
Geologist, right? A geocentric. So we had so Copernicus went and said, you know what? I've looked at the data and all the planets go around the sun and I can make sense of that. If everything went around the Earth, it doesn't make sense. I can't fit it into predictability. So he wrote a book. It was called The Revolution of the Planets. It actually is where we get our term revolutionary. So if I said something that's revolutionary, that's changing the way we view things, it came from Copernicus's revolution of the planets. But what do you think everybody of that age would have said if he said, hey, and he didn't, by the way, he published it after post-human, what's the word? After death?
Posthumously?
Postmortem.
Posthumously.
Oh.
Yeah, but yeah, that's what it is, right? So they published it after his death. But let's imagine that he said, you know what? You guys are all wrong. The planets don't go around the sun. I mean, the Earth, sun doesn't go around the Earth. The Earth goes around the sun. In today's era, he would have been censored, kicked off YouTube and Facebook and Twitter, and he would have said, you're a liar, you're a science denier, because he had a different opinion. In my world, science has disagreements. Do you know the best way to find truth? Debate it. If I'm lying, show me where I'm wrong. Let's have a discussion. But now it seems like everything that somebody says, oh, you're a denier. They call me names and they call people names and they kick you off of things. I think that's really bad for science. Science needs to have the debate. It's like what we've, and it's disgusting based on what we see with COVID and that kind of stuff. A great example of that is the stuff with hydrochloroquine, HCQ. Have you heard of this? Anybody know what hydrochloroquine is? It's basically a treatment for people who have COVID. If you give it to them early, the studies are showing that's a pretty effective way of fighting it so that people don't die as much. And it came to the point where you couldn't even say that online or else you'd be banned and there'd be truth stickers, you're a liar. And then it started going, and the thing is, I had been reading and researching about hydrochloroquine long before it became political. And now, guess what? After all these months of you can't say that, you can't take that and make fun of people, now they're going, oh yeah, hydrochloroquine works, we should have been using it. You just got to understand, you don't have the truth if somebody says you can't say something that disagrees with me. So science is about debating stuff. So in the debate for global change, right? People are called science deniers if they look at something different. Well, so if I start looking at some data about the extent of ice, I'm actually seeing a decrease. And in my opinion, I would say that this decrease in ice is a pretty good sign of global climate change. I think it's showing me information that says we're definitely getting warmer at the surface, especially in the polar regions, especially in the North Polar regions. Southern Hemisphere, I'm not so convinced. And the Southern Hemisphere is where it's sitting over continent. So, I mean, there's all sorts of graphs that you can go look at concerning this. Now, could it be cyclical over areas much larger than the last 30 years, 40 years? I mean, what was it like 80 years ago, 90 years ago? I don't know if we know that. So there's a lot of information that we probably need to deal with, but it's really interesting. And I think it's a pretty good idea that there's sea ice is melting, but sea ice melting doesn't really lead to a rising sea level. So what is the rising sea level a result of? Does anybody know what the answer to that is? Why would the water levels be going up?
Snowfall.
No, it's not that there's more, it's really not that there's more water in the oceans. What happens to air when you heat it? When you heat air, what does it do?
Fans.
What happens to water when water is warmer?
Expands as well.
You have the ocean. Where's the water going to expand?
Upwards.
That only place it goes is up. So the question, so as the ocean temperatures rise, that will lead to a thermal expansion of the oceans, which will lead to a level of rising seas. By the year 2100, how much are the seas expected to rise? Don't look at anything. Give me an answer. So everybody in the chat box, I want you to give me the answer. By the year 2100, 80 years from now, how much sea level rise are we expecting? Whatever unit you use, that's fine. Just put it in the chat bar so we can see what you think.
Like just a guess.
Idea? Aaron?
You don't know, right? So just, yeah, a guess is fine. You can say whatever you want.
Hmm.
That's not that much.
All right, I'm getting a bunch of different answers.
Ironic in this here.
It's ironic. I'm seeing these answers and they're all, reasonably close to each other. I mean, even when people are saying 8 inches to 5 feet. Oh, now Aaron's saying 60 feet. Now would you think that's sizable? 60 feet of sea level rise. Anybody say anything that's considerably outside of this range? If I were to ask you, what is your perception? Like if I said, okay, imagine that you looked at an illustration on a news article or a magazine cover or something, what would they show you to indicate sea level rise? Like think about into your mind, what's the visual picture people will show you for climate change? What do you think?
What I think of is like they show the Earth now and then the Earth when the sea rises, and it shows like different, like how the land changes.
I'm gonna see I think sea level rise, global warming images. Here's one. That's an image. Let's try this. Let me type New York. If sea levels rise by 8 feet, New York and London, I mean, look at this picture. All underwater. Would this concern you? If it were like, doesn't that scare you? It's like, holy crap, we better do something. Our existence will end. Okay, there is a thing called the IPCC. Do you know what the IPCC stands for? IPCC, and you need to know this because this is an intergovernmental panel on climate change. And what do they say? Now, this is a bunch of government people who get together. Do you think there's any political concerns within this intergovernmental, or is this just pure science? Well, the answer is it's a whole lot of politics. There is strong evidence that global sea level gradually rose and is currently rising at an increased rate after a period of little change between the year 0 and 1900. Global warming rose by about 120 meters during the several millennia, 21,000 years ago, that's what they say, and stabilized. Estimates for the 20th century show that average sea level rose at a rate of 1.7 millimeters per year. For instance, global sea level reaches 0.2 to 0.44 meters above the levels and maybe 4 millimeters. So let's go on the high side. 4 millimeters per year. Here's your projections, big spread, but we're looking by the year 2100, somewhere between 100 and 500 millimeters. That's this much. Is that going to cause New York City to be submerged in water? Even at the high end of that range. Does that look like an existential threat? Now, would you care about ecosystems and flooding and roadways on the sea lines? Should you worry about that? Well, I don't know if I should worry about it, but should you do something to protect against that? What's the word that means we should try to stop these bad things from happening? There's a word for it, and you need to know this for my test. Anyone?
What does it start with? Minimize?
Close.
Mitigate?
Mitigate. Yeah.
Right? To mitigate, to mitigation. It's to basically try to stop bad things from happening. There's going to be an earthquake. Okay, let's build our buildings with higher levels of code to mitigate against disaster, right? If I can build a house that can take a shaking without collapsing and killing people, I have mitigated against the disaster. So mitigation and adaptation are important words in my vocabulary to talk about what we should be doing about global climate change. We should be thinking about ways to mitigate and to adapt to a globally warmed environment. Now, does it matter if it's 0.2 meters or 0.4 meters? No, I'm already kind of adapting to it. So what I'd like you to start thinking about are ways to mitigate and adapt to a climate environment that's changed. But something that's important, and this goes back to Abby's original point, is that sea level rise is a lot of thermal expansion. The oceans are getting warmer, and there's an increase in the oceans are big. So I don't know how much that is. But here's another thing. If the ice melts, do you agree that would reflect less radiation? So what could that do to the albedo of the Earth? What would that do to the albedo of the Earth?
Lower.
If it made it lower, what would that do to the temperature of the Earth?
Older.
If I lowered the albedo, if there was less reflected, that would mean more would be
Going through.
absorbed, which would make the temperature go up. So I want to go back to this sheet, right? If I have, here's the event, warmer temperatures. The effect leads to ice melting. That leads to more radiation absorbed. And that makes it what? Warmer temps. So what I started with was creating a cause. The cause was warmer temperatures. Okay, so global climate change, carbon dioxide is absorbing more, blah, blah, blah. Warmer temperatures. That results in things that lead to warmer temperatures. What have I created? What is this called? Your book talks about this. This is a what? Anybody?
Feedback loop.
That is a feedback. or you could say feedback loop. But because the cause was warmer temperatures and the effect was making it even warmer, we call that a positive feedback. That's an example of a positive feedback. Warmer temperatures lead to something that happens that leads to warmer temperatures. Positive, not meaning good or bad. It's not positive like, oh, stay with a positive attitude. It means that whatever the effect it causes, it's like directly proportional, right? Let me give you an example like this. Warmer temperatures lead to more evaporation. Which leads to more clouds, which does what to the albedo?
Reflects.
Higher albedo, which leads to more reflection of incoming solar radiation, which leads to what? Cooler temperatures. What is this an example of?
Negative feedback.
So I create the warmer temperatures and then things happen which lead to a cooling. At least a possible this is possible. The point is, how do we know what it is? How do we know what that is? I don't know. We do science. We try to figure stuff out. We use models. And you know what they figured out about clouds? Based on what I know, you know what they know about clouds in the feedback system? I'm not sure. There's some indications that clouds can be a positive feedback, and there's some indications that clouds can be a negative feedback. Same with aerosols. Aerosols are really great unknown. So the idea being is when we're doing a model, we're trying to predict things. Now, if you look at this climate sensitivity, okay, hold on. Climate sensitivity, initial warming and feedbacks. After increasing CO2 levels, there is an initial warming. This warming gets amplified by the net of feedbacks. Now that's positive. However, there's also negative feedbacks. How well do you think we understand all the feedback mechanisms in the science world? The answer is not really well. If we don't understand true feedback mechanisms, what does that lead to? If we don't know what's really happening, what will that lead to in future predictions?
Unprecise data.
Shannon, you said imprecise data. I think you need to use a different word. That's close. You're really close. Sam, we do this in forecasting all the time. We don't know exactly. And so Shannon, it is imprecise. That leads to what in our forecast though?
Uncertainty.
Yeah.
It leads to uncertainty. So the question is there global warming? Is there global warming? Ask me. Ask me that question.
Is there global warming?
Global warming.
Yes. What's the next question? How much?
Mhm.
How much global warming? And what am I going to give you? I'm not sure. There's a range. What do you call the range of predicted values? That's the ECS, the environmental, or the equilibrium climate sensitivity. So there's an uncertainty in what it is. Some people think it's on the high side. Oh, 5 degrees. And if there's 5 degrees, do you agree that that will have more impact on the globe? Yes. If you believe it's 2 degrees, that will have impact, but it'll be less impactful. Would you agree with that statement? So do we know for sure what it's going to be? No, it's uncertain. So what do we do? Now, let's say that it was 2 to 5 degrees. Is that bad? Is warmer environment necessarily bad? Let's try to think of some positive things, like good things that happen when the earth is warmer. Can you guys think through that? Everybody unmute their mic because it's a conversation. It's hard to have conversations if you're not talking. Think of some good things that come from a globally warmed environment.
Better for agriculture.
It could, why? Maybe.
Because it could lead to, let's say, warmer pressures, which kind of leads to rainfall or something.
Okay. Do you think it might impact? Why did you say agriculture of all the things?
Because it's good to have food.
Because it's good to have food. Would you agree that climate change can impact agriculture? And agriculture is what provides the world with food. Question is warmer better? Well, some areas could be drier. Is that better? No.
No.
Could some areas be warmer and moister? Yes. Could you have too much rain? That leads to flooding. Could you have too much drought? That's a problem. Could it be better for plants? Could you have, what would you get? If it was warmer, wouldn't you get a longer growing season? Couldn't you grow for longer periods of time? Yeah. CO2 in the atmosphere is good for plants because that's what they take in. So what you find out is that plants thrive in a high CO2 environment. So those are good things. More people die by cold weather than they do by hot weather. So you could have less death. Would it change things? Yes. What would you have to worry about then? 2 words. If the agriculture is changing, what would you have to do?
Adaptation.
And
Mitigation.
right? You'd have to mitigate and you'd have to adapt. Do you realize we do adaptation really well? Do you realize right now in Illinois, we get about 4 times as much crops per acre as we did 70 years ago? Why? Because we have better strains. We do genetic modification of corn. And we are able to work on genes and we're able to create plant types that are better involved. They can have more acreage per, or more crops per acre than 70 years ago. We have better strains. They're more resistant to insects. They're more resistant to drought. They're more resistant to too much water. They're more adaptable. That's all good things. We have the technology and the ability to learn to adapt and mitigate. And I would like to see, personally, when we talk about global climate change and talking about adapting to the future, I'd like to see those things addressed, number one. But what does it typically go to? When we talk about climate change in our political environment, what is this usually all about?
Like how to stop or slow down climate change.
How to stop or slow it down? Less gasoline, less fuels. So how do we get less fuels? How do we get less fuels? What's the political environment doing in this country right now? What are we trying to come up with from a political standpoint?
Renewable.
Okay, so Sam, you mentioned this the other day, renewables, right? Like what?
Renewable energy.
No, like what specifically?
Solar.
Solar,
Wind.
wind,
Water.
hydroelectric power. There's a couple of other ways to do it. Geothermal energy. Those are all ways that, those are what we call renewables. What's the problem with renewables?
Don't get as much energy.
Okay, that's what I would consider a real problem, Ryan. They don't get as much energy. They're not very good. And they're also, but from a political standpoint, what are they?
Expensive.
They're expensive. So to get people to use renewables, which is expensive, what do you need to do to fossil fuels?
Make them more expensive.
Make them more expensive. How do you make them more expensive?
Supply and demand.
And what's the way that you do that?
You remove.
What's the easiest way to make them more expensive?
You have to not, there's a lot of places with fossil fuels and oil, so you just pick less where you're getting them from.
You say, I'm going to cut the supply. If you cut the supply by stopping, let's say, the XL pipeline, we drive the cost of fuels up. Have you noticed anything lately at the gas pump? All the prices are going up. Because when you drive that up, that will make renewables more competitive. Now, my personal opinion is that's stupid. I think that's bad. Because who doesn't care about high gas prices? The rich people. How do gas prices affect you if you're poor? I'm assuming that most of you are relatively poor. I mean, right? You're students. You don't have, how many of you are in a career job right now? Anybody care that the prices of gas are twice what they, if they be twice, would that affect you? Just you personally.
Mm-hmm.
Rich people, poor people are going to be impacted by it. How about rich people? No, they can deal with that. I'm just saying, do you see the ramifications of changes, all because they say global warming is our existential threat? I mean, if it is, maybe this should happen. Forces renewables, maybe that's what we ought to be doing. I don't know, but there's an argument, don't you think? We should have that argument, whether or not that's worth it. How much would it be if the United States stopped using fossil fuels? How much would we change on the world stage? Like if you look at the climate accords, and this is what cracks me up. Oh, if the United States does this, we can cut the average temperature increase over the next 80 years by 0.1 degrees. Okay, first of all, that you can even predict that is silly. Second of all, really, whatever. Is that worth it? I don't know. There's political arguments to be made. But do you understand why these things come about? And there's an interconnectedness to everything. And it stems from this concept that global warming is bad and an existential threat. And I'm just having a hard time believing that. Does it have impact? Sure. Am I a denier? No. I think it does have impact. I just don't think it's that bad. And you'll find that most scientists disagree on the levels. They don't disagree that global warming is happening. They just agree on how much and how bad is it. And do you think that argument is legitimate and should be out there in the public forum? Yes. Do you ever notice that it gets shut down though? You can't say a certain thing or else that argument's so there's people controlling your thoughts and you can't have a disagreeing opinion. And I think that's a problem. So you can have whatever you want. So on a scale of 1 to 5, 1 being it's not a big problem at all, to 5 being it's a really, really serious problem, what is your opinion on global climate change? How bad of a problem is it? I've got some 2s, Sam's at a 4, a couple of you are at 3s. You're maybe 2. Why do you think it's so bad, Sam?
Because, the way we look at things, we're gonna say, oh, it's not that bad, and it turns out it's gonna be bad. And it's one of those things where it's gonna be, even though it's gonna be over a long period of time, it's not something to ignore.
Okay. Would you can you accept Sam's view that it's significant at a 4? Can you all accept that he has that opinion? Sam, can you accept somebody who says it's a 2?
It's their opinion.
Are they entitled to it? Can you disagree?
I can.
How bad is, for you personally, how big of a threat is COVID?
Me? Or everyone?
No, to all of you. Show me a number. Okay, Tim went to 0. Avi, you're at 0. Sam, you're at 3. A couple of you guys are 2, 1. Why did you, again, Sam, what that says to me, why is it 3 to you?
Because my grandparents need my help a lot.
I didn't ask that.
And if I get it, I can't
No.
help.
Sam, I didn't ask that. I said, how big of a threat is it to you personally? Like you personally, not grandparents. I'm not saying,
Well,
I'm saying to you personally, are you afraid of COVID for you yourself? Nobody else, just you.
no.
Where are the rest of you guys? Does that change it if I clarify that question? Is anybody worried about it? So, Avi, what do you think about all these lockdowns when you're saying it's a 0, or Tim, you're saying?
Well, for me personally, I don't think it's that much of a threat. I mean, I'm a healthy person as is, and it's like, I don't know, it's for someone to be, I don't know how to explain this, but if someone is healthy enough, so like that's obviously my own personal responsibility to take care of myself and be healthy enough to, as in where my immune system is good. And I don't know how to explain this.
Well, no, I think it makes sense, right? And so do you agree that we should have this lockdown 5, or do you say, no, we shouldn't have a lockdown? What's your thought on that?
To a certain extent, yes and no.
How about the rest of you guys? What's your view on that?
If you have a 99.9% of surviving when you drive a car, you still do it every day.
So, and I don't want to necessarily get off the rails talking about COVID, but do you understand that what you are asked to do is you make a cost-benefit analysis, right? You're making a cost-benefit analysis, and you go, you know what, my life is messed up. I want to go back to it. And then somebody else goes, well, I'm worried about my grandparents. So that's your own analysis of it. And that's important. And we need to discuss this. It's a hard conversation to have, but it's an important one. The same is true with global warming. We have a cost-benefit analysis on whether or not we take action, or we don't take action, or how much action we should take. And how do we come to a concurring understanding? How can we come to an agreement? I mean, you get Greta, what's her face, Thunberg? No, Greta, whatever.
Yeah,
and she's
that's it.
screaming at people. I'm like, I'm going to be yelled at by some punky 18-year-old. Sorry, I'm not stupid enough to accept that. You want to have a conversation with me. You don't have an 18-year-old tell me about it. What is your thought on the significance of these things and what should we do? So give me some solutions. Give me some solutions. What would be a good solution to help combat climate change?
I guess we could put more money in the political spectrum towards more research. So there's a little bit better understanding between the two sides of people who do believe it and who don't believe it.
Okay, Shannon, just so you know, and I'm just going to give you the inside scoop. Oh, there's plenty of money. But you know what is not allowed? If you don't tote the company line, you don't get funding. If you don't say things like, oh, global warming's bad, you're not going to get funded. That's a problem, in my opinion. And it's amazing how many scientists I know who go, this is all garbage. What you see is garbage. It's terrible science. And that's political influences in science is a dangerous thing. But I get what you're saying. And certainly that's a reasonable thing to say you want. I'm just wondering if there may be some other things. Like, how many of you are willing to only drive electric cars? Why not, Lena? Teslas are cool.
There's just something about gas. Like, I don't know. I think it's more opinion based. Like, I wouldn't want to drive an electric car because it's not like a car to me at that point. But I don't know.
How many of you would like a Tesla?
Oh yeah.
Teslas are cool. Why don't you have a Tesla then, Zach?
I don't got the money for it, dude.
Oh, okay. So how much are you willing to spend for stuff, for electricity, to make it worth it? How much more increase are you willing to personally do to help the environment?
What do you mean, like increase in?
Like if I told you, hey, you know what? Are you for a $2 a gallon gas tax? If I said, that's my proposal to you, $2 a gallon, we're going to increase it. That'll cut people's usage of gasoline down. Are you for or against it?
I mean, it's gonna go to like how much am I gonna be spending on gas a year, and if it goes over the price of like what a Tesla cost, I'm just gonna switch to a Tesla instead, because then overall for the year my price will be down. Although I'm paying electric.
Can you afford it right now? Do you want a $2 gas? Would you vote if you said, "Hey, we're going to ask you"? It's a democracy. You actually get an opinion. Would you vote for that? How many of you would vote for a $2 a gallon increase in gas?
No, not at all.
Raise your hand if say thumbs up or thumbs down. I want you to see something. Okay. Do you understand what you're doing? Isaac, what'd you put? What'd you say?
I'm thinking about it. I'm not sure.
Okay. What's interesting is, do you see how oftentimes people will go, oh yeah, I think we should go climate change, blah, blah, we should fight it, blah, blah, blah. Are you willing to pay for it? No. True. How many of you, like, this question doesn't work very well in COVID world, but let's say that you were coming to COD. How many of you carpool with 3 people? Why not? Isn't it less money? Wouldn't it clear up congestion on the roadways? Wouldn't it give you more parking spaces? So why don't you carpool? Tim, why don't you carpool? Look at all the good things. It cuts down on CO2. It costs less money. There's less traffic on the roads.
Because people think individually at such a small scale.
Oh, so what are you telling me? It's inconvenient? So do you understand? You're saying, well, yeah, that's a great idea, but it's too inconvenient. I'm not going to do it. Is that not humans or what?
I don't really care to be honest.
I was like, I don't want to do it myself. And that's, do you have the right to do that? Or should the government tell you how you should do it?
No, I have the right to do that.
Okay, so there's some of you, I mean, do you understand those are the questions that you have to ask yourself. Global warming, how many of you think we should ban XL pipeline or ban fracking? Yes or no, ban fracking? Okay, are there costs? Are there benefits? You have to make through that determination. Here's something that's really interesting. You know what one of the greatest fuel sources in terms of density, of energy density is?
The nuclear.
Nuclear. Nuclear is unbelievable. See, solar power and wind ain't gonna solve our energy demands. We would have to cut our demands by 50%, 60%, 70% to make it somewhat reasonable. But you know what could do it? Nuclear.
Isn't it really unstable?
You're against nuclear. Give me your thumbs up, thumbs down.
I don't know enough about it.
Okay, so Tim, you're like, I don't know that much about it. Aaron, are you up or down? Can you give me a up or down? It's an up, okay. Isaac, what do you on that one?
I don't really know a lot about nuclear energy either.
Okay, so you don't know that much about it. Great. I get it. Do you care, really? I mean, are you making the decision? But the question I'd have for you is, when's the last time you heard that discussed in the public arena? Like, seriously.
Big
Like,
no.
oh, we're going to ban pipelines and we're going to not export oil and this, that, and the other thing. But when's the last time you heard a real good discussion on nuclear power? Why not? I don't understand that either. If you're really concerned about global warming, and I know a lot of physicists who are, guess what they want? Nuclear power. But we're not getting it, so what's the reason? If you think science and reason and logic and the good of the world is at stake, I think you'd be sadly disappointed. I think there's a lot more to it than just doing the right thing.
I think a lot of people are thinking that it's too dangerous and they're just.
Well, yes, they're thinking that, but are they, when you say they're thinking that, are they really thinking that? Or are they just kind of going, yeah, it's too dangerous? How much research? At least a couple of you are like, well, I don't really know.
It's
If you've done the research, it'd be interesting.
it's probably got to come down to like power and money, in my opinion.
I think it does, but I'm more interested in the science of this class so that you understand there's a difference between what you hear in the media and what is actually going on in the scientific world. The scientific world is much more interested in science, but even the scientific world is full of people who are really sinful. They have some real big issues and they don't tell the truth, and it's disgusting. I wish science.
A major thing in the scientific world would be bias, right?
There's
There's a lot of bias.
lots of bias in people who are scientists. And unfortunately, I see what bothers me is I see it with students coming out of high school. Because high school teachers are going, and the key is, oh, climate change, and it's terrible, and you should all do this stuff. And then you come into college, you're like, oh, it's going to kill us all. It's not really. You're being taught by people who don't really know that much. So to me, when you're in high school or junior high or even college, you ought to be learning, not being told what to believe. Learning about it. And I can argue both sides of a coin really well, but I'd rather see you understand what the science is. So let's review. What are some of the things we did today? Do you understand the difference between global warming and climate change? Okay. Do you understand how greenhouse effect is necessary? It's actually a really bad term. It's the atmosphere. It's the way the atmosphere works. Super important. Do you understand that carbon dioxide concentration levels are going up because of the burning of fossil fuels? There's no question on that. That will result in additional outgoing long-wave radiation from the Earth to be absorbed by the atmosphere, which will result in more coming to the earth. And that will result in a warming temperature. The real question is, well, how much warming? How much more warming? And that's a lot of uncertainty in there. But even with that warming, is that a bad thing or a good thing? I don't know. Do you all agree that we should be able to adapt and mitigate against those threats? And we could be talking about that, and we can all agree to that. When I start looking at all the things that everyone can agree on, it's not nearly as bad as what it appears to be. You know, would you all agree that better efficiency of fossil fuel burning would be good? Would your car being more efficient be good? Would spending less money on electricity because you use less of it be good? Yes, this is all good. But there's a limit to how much we can push people and whether or not it's all good. But we can move forward little by little, and I think we're doing okay. I don't know. I just want you to be more aware of when you hear on the media, when you hear stuff, be discerning. Go, wait a second, that seems crazy. And then you can look at it and go, okay, I don't know if that's really true. And then you do some independent research. There is climate, this is a book I want to read. Apocalypse Never. Something, let me see if I can find this. Apocalypse Never. This is a book I would really like to read. Oh, this is a summary of it. It's by a guy named Michael Schellenberger. And of course, guess what animal is on there? Oops, where is it? The polar bears. Do you agree with that? This guy, okay, so there's conservatives and liberals, and they don't seem to, well, whatever you want to call each other. They don't necessarily get along really well right now. But I heard a very strong conservative interview this guy who's fairly liberal. He's pretty liberal, but it's amazing. Do you know why? Because he's just talking rationally. And he's giving you good facts, and you're going, you know what? There are good solutions, but don't believe everything you hear. So if anybody is interested, I'll give you extra credit. You read this book, even if you just buy what was this book here? The summary of it, because it would be really beneficial if you want to get involved on what it is, because it's like, it's in between. There's no problem, and it's going to kill everyone. There's going to be an apocalypse. I heard a 2-hour interview that was one of the best interviews I've ever heard. And it was like, I agreed with everything. And I thought that was awesome. So just be aware that politics gets in the way of good science. Humans get in the way of good science. And don't stifle people with a different opinion than yours. Have a discussion. Don't yell at each other. Don't call each other names. Just have the discussion and understand people can come to it from different perspectives. And you're not as far apart as you may think you are. Okay? So on Tuesday, we're going to finish up, talk a little bit more, just kind of rough through all this stuff. We'll do the station model, so make sure you've got a good grip on how to read a station plot. And then your test will be next week. Now, Tuesday, Thursday, we're still going to have class. We're going to go on to the next unit, but it will not be the full class. I have to leave by 3 o'clock. But the test itself, I will give you like a 5-day period that you go online and take the test. So you have some flexibility. But here's what you need to do before then. You need to write up your good set of notes, and you need to study as though it's an in-class test. Then when you take the test, you'll be ready to do it, open note. But don't count on open notes just because it's open note, because you won't have enough time to go find everything. You need to know where your information is, and then you can use it, okay? So you don't have to memorize things, but organize things. Organize, not memorize. Mitigate, and what's the other one? Adapt. Okay? Questions, comments, concerns?
How long do we have to take the test?
The test will be I think it's 90 minutes. It might be 2 hours. I think there's also essay portions which are not timed. You can do that independently. The test should not be so long that you don't have time. So if you have a blue card or something, don't worry about it. It will tell me when you turn it in. And I'm not going to die. I'm not going to kill you if you're a couple of minutes late. You can still turn it in. So, but it keeps me aware that if you're going 6 hours, this is not acceptable. Okay. So there is a time limit to that. And the rest of it, and you should be fine. So you don't have to ask for more time. I'll see that. If there's a problem, I'll talk to you after the event. Fair enough. And we can go over any questions you have. We'll go over on Tuesday. I hope you appreciate this. I hope you've learned something. You know, I want to change the world. I can't change a lot, but I can change you, hopefully. Make you better, make us all better. I hope you're feeling listened to and respected, and you can have a diversity of opinion. Let's just keep it that way, okay? All right, guys, enjoy your time. I will see you all next week.
Can we talk to you for a minute?
Absolutely.